learners, welcome to this lesson. I'm teacher Agnes. I'm going to be taking you through a Form 4 topic in mathematics, statistics 2. This is the first lesson of this topic and we are going to be discussing about assumed mean. So in the previous topic, statistics 1 that was learnt in Form 2, we learned how to calculate mean using a different method. In this particular topic, we're going to learn how to use the assumed mean to calculate the accurate mean. Now I'm going to start by providing us the formula that we use when we have ungrouped data. So in case you have ungrouped data, the actual mean is given by, so we take the assumed mean and then we add to the summation of t divided by n. So like I said, A represents the assumed mean, okay? And this mean, you come up with it from the data provided. Now t represents the difference between A and x. So once you do an example, you see the difference between A and x. So you take x minus A to get t, and then n represents the number of terms in the data. So if you have like 5 masses that you want to calculate their mean, then n will be 5. If you are comparing marks of 10 students, then n will be 10. So we're going to do an example and try to apply this formula. So we are going to attempt this question where we will use the assumed mean method to determine the mean of 495, 496, 499, 500, 500 again, 503, 504, 505, and 507. So the first step is to determine the assumed mean. So just like the word suggests, you're supposed to assume it, guess from the values provided. So in this type of data, where values are ranging from 495 to 507, you cannot assume a mean of 203 because 203 is not within the values that are given. So the best way to come up with the assumed mean is to get the value in the middle of the data. You notice that the data has been arranged from the smallest to the highest. So the smallest value, since these are 9 data entries, we have 1, 2, 3, 4. The fifth one is, in the middle of the data. So our assumed mean for this particular data will be 500. Now the next step is to create a table where we have 2 columns. The first column will outline the values provided here. So we have x. So like I said in the introduction, x represents the values provided in the data. So we have 495 followed by 496, then 499, 500 twice, and then 503, 504, 505, and then 507. So once you outline the values provided in the data, we are going to calculate our value of t. So t is like the difference between the values provided and the assumed mean. So t is given by x minus our assumed mean, which in this case is 500. So now working this out, the first value of t will be 495 minus 500, which is negative 5. Then 496 minus 500, which is negative 4. 499 minus 500, which is negative 1. 500 minus 500 is 0. 500 minus 500 is 0. 503 minus 500 is positive 3. 504 minus 500 is 4. 505 minus 500 is 5. And the difference between 507 and 500 is 7. So remember, in the formula, the mean is given by the assumed mean plus the summation of t divided by n. By summation, we mean the sum of the values of t. So if you add all these values, you should be able to obtain 9. All right? So substituting these values in the formula, the assumed mean is 500 plus the summation of t. All these values of t added, you obtain 9. Divide by n, which is the number of data entries in this particular question, and we found that they were all 9. So divide by 9. So this becomes 500 plus 9 divided by 9 is 1. And if you add the 2, you obtain your value to be 501. You could be asking yourself, what if you chose a different value for the assumed mean? Let's say, for instance, 502. Would it still give you the correct answer? So the answer is yes. So it doesn't matter the assumed mean that you choose, as long as it is within the values. Choose the one that makes your calculations easier, and the best one is the one in the middle. So now we're going to look at another example where the data is some sort of grouped. So from statistics 1, we know that when you have grouped data, we always have frequency, which represents the number of times a particular number occurs in a set of data. So the only difference between this formula in grouped data and the formula in ungrouped data is that we will have frequency in it. So the mean is always given by the assumed mean plus the summation of ft divided by the summation of f. Alright? So A represents the assumed mean, F represents the frequency, T represents the difference between A and X. So Ft is a product of the two. And then F represents the frequency. So we're going to do an example that has grouped data, and then we see how this is applied. So we're going to attempt an example that involves grouped data. So we are required to calculate the mean mass, and we are provided with the mass and the frequency for every mass. So the people that weighed 54 kilograms were 6. So that is what frequency means. It represents the number of times 54 occurred. The number of people that weighed 55 kilograms were 7, 56 kilograms were 5, 57 kilograms were 3, 58 kilograms 2, 59 1, and 61. So when it comes to, getting the assumed mean, you can choose to get the value in the middle or even use the one with the highest frequency. In this case, we are going to use the assumed mean as 57. Now we're going to start by creating another table so that you can calculate all the data that is required. So the first one is X. So the mass provided here represents X. The data entry is given. So we have 54, we have 55, we have 56, 57, 58, 59, and then 60. Then we have the frequency, so we're going to record it because we need it to calculate Ft. Remember, the formula had the summation of Ft. So the frequency is 6, 7, 5, 3, 2, 1, 1. Now we're going to calculate the value of t, and t is given by the assumed mean, is given by x minus the assumed mean. X in this case is 54, 55, and so on. So we have x minus 57. So now, the first value of x is 54. 54 minus 57 is negative 3. 55 minus 57 is negative 2. 56 minus 57 is negative 1. 57 minus 57 is 0. 58 minus 57 is 1. 59 minus 57 is 2. 60 minus 57 is 3. So now, having calculated the value of t, we're going to calculate ft, which is a product of f and t. So ft, so we have 6 times negative 3, which is negative 18. 7 times negative 2 is negative 14. 5 times negative 1, negative 5. 3 times 0 is 0. 2 times 1 is 2. 1 times 2 is 2. 1 times 3 is 3. For us to be able to apply the formula, we have to get the sum of ft. So you add them all up and you obtain negative 31. You also need to add up the total frequency, which you're going to obtain as 25. So having created this table, you're now going to apply the formula to obtain the required mean. So mean, like we stated, is equal to the assumed mean plus summation of ft divided by summation of f. So this is equal to, the assumed mean is 57, plus the summation of ft. If you add up values in this column, you get negative 31, and divide that by the summation of f, which is 25. So working this out, we obtain 57 minus 1.24. Because negative 31 divided by 25, you get a negative answer. So negative 1.24. So subtracting this, you obtain 55.76. So the mean mass for this data is 55.76. Now we have other types of questions where the values, for instance, the values of mass would be given as a range, say 50 to 55, 55 to 60, and so on. So we are going to do one of those examples. So now we are going to create another table where we are going to calculate the values that we need so that we can use the formula to obtain the mean mass. So starting with the mass, we have mass provided as a range of values. The first one is 100 to 103, and then we have 104 to 107. We have 108 to 111, and then we have 112 to 115. Now, remember this is a range of values, so we need to get the midpoint of these values so that they can act as our x. So x is a midpoint, and how do you obtain the midpoint? You add the two values and then divide by 2. So this would be 100 plus 103, divide by 2, you get 101.5. So then we add these two and then divide by 2 to obtain 105.5. Next, we add 108 to 111 and then divide by 2 to obtain 109.5. Then finally we add 112 and 115, then divide by 2 to obtain 113.5. Now, having obtained the value of x, we are now going to get the assumed mean based on the nature of these numbers. You notice that they are all 0.5. They are to one decimal place, and that decimal place is 5. So we will get an assumed mean that is in this nature, so that it is easy for us to calculate. Now, in this case, I'm going to choose the one with the biggest frequency, or a value, within the range that has the biggest frequency, which is 42. And the value of x for this class is 109.5. So the assumed mean will be 109.5. Now, our next column is going to be the value of t, which is given by x, minus the assumed mean, which is 109.5. So 101.5 minus 109.5 will be equal to negative 8. 105.9 minus 109.5 will be equal to negative 4. 109.5 minus 109.5 will be equal to 0. And then 113.5 minus 109.5 will be equal to 4. Having obtained the value of t, and we have the value of f in the first table, we are now going to populate the second table with the value of f. So f is the frequency. So for the first one we have 1, the second one we have 15, then 42, and then 31. So with this data, we can now calculate ft, which is the product of f and t. So negative 8 times 1 is negative 8. Negative 4 times 15 is negative 60. 0 times 42 is 0. 4 times 31 is 124. Now remember, in the formula, we need to get the sum of ft. We also need to get the sum of the frequency. So if you add up the values of the frequency, you will obtain 89. If you add up the values of ft, you will obtain 56. With this now, we can apply the formula. So remember, the mean is equal to the assumed mean plus summation of ft divided by the summation of f. So this is going to be equal to, our assumed mean is 109.5 plus summation of ft is 56, all that over the summation of f, which is 89. Now this will be equal to 109.5 plus 56 divided by 89 is 0.63. Adding this up, you will obtain 110.13. So the mean mass for these items is 110.13. Now we have looked at 3 different examples, starting from ungrouped data, grouped data where you do not have a range of values, and grouped data when you have a range of values. So now I'll give you one question so that you can practice with it. Now, to practice the skill that we have learned, you will work out this question where you will calculate the mean mark for the data provided. Thank you for being in this lesson. See you in the next lesson.